Consider the following system of equations. Determine the solution of the system, determine the equation of each line, and then test your solution in each equation to check if it confirms. So we know that this given graph is a system of equations because it contains two different lines. Because it contains two different lines, that means we're going to have two different equations, making it a system of equations. So let's look at our first question. We need to determine the solution of the system. To find the solution of the system, we simply have to see where our two lines intersect. So looking at our graph, we can see that the intersection point is right around here. Now we just need to find the x and y coordinate of it. So we follow this line all the way down, and we can see that x is positive 2, and then we follow our intersection all the way to the y-axis, and we can see that y is positive 4. So therefore, the solution is where x equals 2 and y equals 4. Now let's move on to b, where we want to find the equation of each line. So let's start by finding the equation of our blue line. Well, to do this, we're going to use y equals mx plus b, where m is our slope and b is our y-intercept. So let's start with finding our slope. We know the slope is rise over run. So let's find the rise and the run of our blue graph. To do this, we need to find two different dots on our graph. So let's use our intersection point, and then we can either use the point up here or a point down here. I'm going to use this point right here. So to get from our first dot to our second dot, we have to go up 1 and to the left 1. So our rise is positive 1 because we move up 1, and our run is negative 1 because we're moving left 1. So positive 1 divided by negative 1 leaves us with a slope of negative 1. And then b is our y-intercept, so looking at our graph, we can see that the blue line crosses the y-intercept at positive 6. So now we plug m and b into our formula. So we have y equals negative 1x plus 6, or y equals negative x plus 6. So now we have the equation to our blue line, so now let's find our red. Again, we are going to use y equals mx plus b. Let's start by finding our slope. Again, our slope is going to be rise over run. So let me clear some of this stuff here on the graph. And then let's find two new coordinates on our red graph. Well, again, we'll use our intersection, and then we can use our next intersection on the graph, which would either be up here or down here. Let's use this one. So to get from our first dot to our second dot, we move up 1 and to the right 1. So our rise is positive 1 because we moved up, and our run is positive 1 because we moved to the right. So positive 1 over positive 1 gives us a slope of 1. And then our b-intercept is wherever our red graph crosses the y-intercept. So that would be right here when y equals positive 2. So b is positive 2. Now we fill in our m and b into our equation, and we get y equals positive 1x plus 2, or y equals x plus 2. So now we have the equation to our blue graph and our red graph. So looking at our final question, we need to test our solution. So to test our solution, we're going to take our solution from A and plug it in to our blue graph and our red graph. Let's start by plugging it into our blue graph. So we have y equals negative x plus 6. Wherever we see a y, we're going to replace it with a 4, and wherever we see our x, we're going to replace it with a 2. So we're going to have 4 equals negative 2 plus 6. Well, negative 2 plus 6 is 4, so we have 4 equals 4. Because both sides equal the same number, we can check that our solution is correct. Now let's check for the red graph. We have y equals x plus 2. And again, we're going to replace y and x with 4 and 2. We have 4 equals 2 plus 2. Well, we know 2 plus 2 is 4, so we have 4 equals 4. And because both sides equal the same number, our solution is correct.